Welcome back, generals, to another Let's Fix Generals 0 Hour to make the best game ever. Okay, so last session we were struggling with with this function collect vtable entries, where we basically want to have a stride of vtables, vtable pointers across the base classes, going up the hierarchy, right? I have a new idea how to implement. I think we need to treat the virtual destructors and other virtual functions separately. Yeah, I think so. So if we have the CPP types here, I was thinking that maybe in the class, here we should create a function. Count without detours. So vtable entry. Vtable entry. We say get virtual get detour 1 0, get detour 0. We need to pass functions, and yeah, and then detour 1. So functions for yeah, and then a get get regular, or get get non detour. Is that a good name? Get maybe we just say get get maybe we just get index t index. Let's say a comment get vtable entry without, or get vtable entry without detour. Get first detour if present. Get second detour if present. Okay. There we go. Oh boy. Okay, and then here we will we will say okay, so basically we say for vtable entry, I wonder if destructors are always at position 1 or not. I don't know. But okay, we can say entries. Here we do the same thing as this one here. And we say here if vtable if is constructor or destructor, and then here return this thing, right? Otherwise return null pointer. Yeah. Okay. And then for destructor 1 we say int count equals 0, and then we say if plus plus count equals 2, then we return this. No. Okay. Okay, so this will get us the first destructor and this the second one. And then here get function. Here we will get the functions that are not destructors. Virtual functions not destructors. Here we simply need to say if function is that, then we continue. Wait, index. I think we need to have an int count. We say index t count 0. And we say here if plus plus count equals index plus 1. We say if count plus plus equals index, then we do return vtable entry. And if it's a constructor, then we continue. Is that correct? Let's think about it. So we give it the functions. There's an index. Index is okay. So let's say we give it index 0, then we have count 0. Count 0 equals 0. So we return the first. Yeah, I think this is correct. How about here we say count plus plus equals 1. Then it matches this 1 here. And it matches this count. Yeah. I think this is correct, probably. Okay. Then good. Now with this equipped, we should be able to do something. Let me see. Collect. I wonder if we should have a function collect detours, detour 1, collect v detour 1, 0, maybe. Yeah. Let me think. Retail entry. Is virtual destructor? What is this function? Oh. Oh boy. So I think we need one cluster. Yeah. So I think we create a function here. This collect detour 0. But then we need something else here. vtable entry is not enough because we need to have I think we need to have a struct vtable vtable descriptor vtable records, I don't know, vtable records, and then in there will be the vtable entry pointer, and then we vtable entry, and then next to it we put a is bool. We need to say, let's make it a member. We need to say if it's leaf. Or let's say is base. Is base. Is base. Yeah. And then we would have this here. out vtable records. Okay. Yeah. Yeah, I think we can do that. Yeah. Okay, let's copy this here. Okay, so the idea here is now that we, that we collect them separately. We collect the detour destructor 0 and destructor 1, and then the rest is kept separate. And maybe this makes the logic easier, because essentially behavior between destructor collection and other function collection is different, right? That's my reasoning here for this bullshit. Okay, so here we would say we would also have this here. So we have base class type, and then we collect this and collect that, base class type, yeah, and then we don't do this, and then here we say this pushback base we have class type dot vtable vtable dot get detour 0, yeah, and then get detour 0. Get destructor 0. M functions. And so we create here the vtable records. And then we say vtable record dot vtable entry equals that. And then vtable record dot m is base. Oh, that's a question now. Oof. Oh, that's. I mean, if this records thing is empty, then we know it's a base. But there can be multiple bases with destructors, right? How do we deal with that? I'm not sure. So basically here, if vtable record dot vtable entry is not null pointer, then we push back, right? Yeah. Okay, but how do we know the base? Is it the base? For the first one, yeah. For the second, I'm not sure. There must be a way, but I'm not seeing it right now. Well, basically, hold on. If this class type, yeah, actually, hold on. If base class is 0, then yeah, it is base. Base class is dot empty. There we go. Yeah, I think that should work. Yeah. Yeah. Okay. And then basically we do the same here, but with detour 1. There we go. There we go. And then here we would say yeah, here we will make a change and say vtable entry. We do a vtable entry index. Say this is without detours. Detours. Okay. And then here we do entries. No, actually, vtable entry function. No, actually, I think we need to say entries and then vtable entry and vtable entry. I think we can make a const, and then here we would say if vtable function index is not invalid index, then if functions vtable entry in the function index dot is detour, then we do the same as this one here. Count where are we here? Detour count, and then we say here if detour count plus plus equals 0, then we do I think this can be gone. Then we do collect detour 0. And I think this one needs to be indented, else there we go. Let's make here indentation as well. Okay, and then here we need to put std vector vtable records. We say vtable records, and class type. There we go. else detour 1. Yeah, and then here we can say continue, and then otherwise we do this one here. Well, obviously we need to do something here, some logic here and here, right? Maybe this should also return a vtable record. No. Yeah, for consistency, I guess. Collect. Collect vtable entries. Collect. How about we call it collect virtuals? Vtable index. Okay. Then we create a new function here. Let's comment this out here. Then we do this. Vtable records, collect virtuals, vtable records, and then vtable index. Okay. And then we have records, vtable records, const. Well, like this. Okay, so basically here it will do something, and then here we will do a similar thingy. Yeah. Okay. Okay. So far so good. This I think makes sense. Maybe. Let's test this here first before we continue. Let's put a breakpoint in here. Let's see if it actually works. So basically, we should only ever see destructors in here and these records. Okay. Let's see. 2. 2 destructors. That looks good. Yeah. And then here, so this one has 2 and 5 index. 2 and 5. Now we are here, and this one has also 2 and 5. That's not right. Actually, it is right. Yeah, it is right. Yeah. Yeah. I don't know if it's really necessary to collect detour 1 then. Yeah, probably is. Oh, it doesn't matter much. Okay. I think this works correctly. Let's put a breakpoint in here and here and see if they look always good. Here we have 1. Let's just do our first one here. 3. Yep, looks good. 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 Yep. Yep, looks perfect. Yeah. Actually, let's also check if is base true? False. Okay, so this is a base and this is a base. False. Okay. Makes sense. Okay, here we have, so this one should be a base. This one is not a base. This is not a base. This is not a base, and this is also not a base. Okay, that's pretty cool. Okay. This looks good to me. Check another one. True, false, false, false. Okay. True, false. True, false. Yeah, this looks very good. Okay, here we have 5. Let's look at these guys. Base, yes. False. Yeah, looks good to me. I think this is correct. So the destructors we have covered. That's nice. This gives me hope. All right, let's see the next step. Now it's getting complicated. Collect virtuals. So now we only look at virtual functions that are not destructors. Yeah. And we hope that we can somehow get them to align properly. Yeah. Okay. Let's take this here as our starting point. Okay. And basically we call this, we call that, and vtable index. Let's say vtable records. Vtable records dot m. Okay. Vtable record dot m is base equals. We copy this stuff here. Okay. And we also need to save vtable. Yeah. Okay, so vtable in hold on, we still have some error here. We have some error here. We need to say base vtable index vtable index. I think here we need to add vtable dot get count without detours. There we go. M functions count without detours. Yeah, I think this makes sense. Yeah, maybe. Okay, this looks promising to me. Base. If vtable is smaller than... hold on, this is wrong. Vtable. This is wrong, yeah. So here we would say count, also count without detours. And then here we actually need to call get this vtable index thingy. Get m functions vtable index. Do we expect this to never be null pointer? Maybe. Let's put an assert for now. Assert is not null pointer. Yeah. Okay. Okay, it looks risky, but it could be correct. Yeah. Okay, let's see if that works. Let's go in here. Code looks pretty clean to me. That's a good sign. When you see that your code gets overly complicated with conditions and loops and function calls, it's a good sign that you're on the wrong track. But if it looks clean and the flow is clear, then it's typically a good sign. Yeah. Yeah, because if the code is getting chaotic, then it means you're overcomplicating things, and you need to break it down in different ways. Most likely, this is what happened yesterday when I wrote this function here. It became bigger and bigger and more complicated, and I didn't understand anything anymore. Yeah. Okay. So collect virtuals. Let's see. So this one has a vtable. Yeah. Okay, it has this idle function here. So we have base class is 1. vtable index. So we will refer. So vtable index 0. By the way, I think we have an error here. Yeah, we have an error here. vtable index. We need to increment it here. Let's fix that. So post increment. So it will start at passing 0. Could also make it on a separate line, maybe. I think it's fine for now. Or do we put it maybe at the very end? Hold on. Maybe we put it here, plus vtable index here at the very end. Maybe that's a bit better. Okay. Yeah. There we go. Okay, so vtable index is 0. We have one base class. Yeah. So it's a recursive call. Let's go to call stack. Okay, the index is still 0. Our base class is 0 now, and we go down here. Now this count should return 1. This count should return 1. Let's check that. There we go. It returns 0. Oh, because it only has 2 destructors. Okay, that's fine. Okay, so then this means we don't enter here, because this one returns actually 0. And 0 is not smaller than 0. Okay, so what happens here is this one will increment to 0 and will stay like this. And this one should return 1. Right? We have function 3, right? here, yeah, 3. So this one, 1, 2, and this 1. Okay, so we have 1 count, yes. And so 0 is smaller than count, so we go in here, and now we get the first one, which should be this idle function, and it is, yeah. Sample sound idle, and it is, oh, base. This is not correct here. This is actually not correct because this is not correct. I think here the base, it's base if this one is simply empty, right? Because there's only ever one base, at least for this one here. Out vtable records dot empty, and then it's a base, right? But then the question is this one here. This is not correct then, because what if the most bottom class doesn't have a virtual destructor, but then one higher up it has a virtual destructor for the first time? Then we probably need to say maybe we need to say if this is empty or if this is empty. Could that be? If this is empty or that is empty. I would put the same condition here. Maybe. Let me think about it. Yeah, maybe if it is empty. Oof. Yeah, but I'm not so sure. I'm not so sure. Yeah. Could be wrong, but the problem is, let's visualize it. So let's pull out paint here. Let's make a nice canvas. So we have here our a base. Let's make a new. So how do we visualize it? Yeah, let's go here. So this is a top class, yeah, and then this one has, it has two base classes, and then this one has two base classes, and this has one base class. Yeah, let's put some lines here. So it looks like this, this, and this, and this. Yeah, and then, so let's say this one has a virtual destructor, and this one, and this one, and this one, but not this one and not this one. So it's so here we have one, here, here, and here. Okay. So the virtual destructors in here, yeah. Oops. I didn't mean to write a line here. So that means we go down the line here and we visit this thing. It doesn't have a base class. This one has a base class. But yeah, okay, so here it would work correctly on this if it would go in here first, but if it would then go in here, then here it would say that this is not a base class for a virtual destructor because it does have a base class here, and the vtable record is not empty anymore if it has visited this side already, right? So this one, this virtual destructor here will be classified as not the base, but it would be the base because on this side it would be the first virtual destructor that does not override any other, right? This one overrides the virtual destructor from either side, right? And this one does not. This one does not. So that's why it would have to be classified as base, but it won't be classified as base. Huh. Base class is empty. Base class. How about we say I think I have an idea. How about we return the count that it collected from this call. So we return an integer here. Yeah. So here we say return 1 and here return 0. Yeah. Return 1 and return 0. And then here we say integer int detour count 0, and then we say here detour count plus equals that. No. And then we say is base if collect detour 1. Okay, let me think. I am under the impression this is not quite right. So we are at the bottom. It returns 1. Then if we have two base classes, both have virtual destructor, it then would have 2 here. And then we could check it here. Does it make sense to count 1? The problem is that it will higher up, it will reset the counter. So we call it recursively, and then it will be 0 again on a new. Does it make sense to return this plus this and this? Or I can just say detour plus equal 1. So then in the most bottom leaf, it will be 0. And then it will go up. Yeah. This might work. Is base, and then we would say is base if detour count is 0. Yeah. Okay, let me put the same here. Mm-hmm. Yeah. Let's comment out this function here because we haven't been using it yet. Maybe we don't need it. Okay, this might work, but it could also be that I made a mistake thinking. This one, I think this one is correct and sufficient. Yeah. Okay, let's stop debugging and restart. Let's I think now we need to check those first again. Okay, we have a compiler error actually. Must return a value. Oh. I think we can just do the same. Yeah, let's do here virtual count. Return virtuals count. Plus equal 1 plus equal yeah, I guess you can do the same here. Let's put this here. Virtuals count equals 0. Okay. Let's see if that works then. Okay, let's check the detour first, if that gives the correct results that we would expect. Okay, so we expect that this one is a base and this one is not a base. Yeah. This one is a base and this is not. Okay, it seems right. Base. Let's remove this one here. Base. Not the base. Okay. Let's go to something more complicated. 4. Okay, here we have a base, another base, 2 bases. Okay, does that make sense? Let me see, 2 bases. Mm-hmm. 2 bases. Here, class type. We have base classes. Yeah, base. It's hard to follow this here. 9 and 5. 9 and 5 watch. 9 and 5. There we go. So this one has also 0 base classes. Oh? This was the 1 base class. Okay. Okay. Then I think it makes sense. Yeah. Yeah. So it could be correct. It could be correct. Yeah. That's what I say. 5. True. False. 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 True. False. 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 Okay, I think it probably makes sense. Yeah. Okay, let's check this guy then. Collect virtuals. Okay, let's see what we have here. Tint envelope. 0. Okay, let's see. Base class. 2 base classes. 2 base classes. Virtuals count as 0. Okay, so this base class has only the destructor, very likely then. Okay. Yeah, okay. And then count without detours is probably 3. So this one is smaller than 3. Vtable entry CRC xfer. CRC xfer. Intent envelope. Okay, hold on. Base class is 2. Count without detours. Hold on. I'm a bit confused right now. Shouldn't a CRC xfer So this one is 2 2 base classes, 1 and 16. Let's punch that in. 1 and 16. Memory pool object and snapshot. And snapshot has... Oh. Why is the vtable empty? That doesn't look right. That doesn't look right. Snapshot. It has It has 3 virtual functions. I'm confused. Snapshot has 0 virtual functions recorded here. That is certainly unexpected. Snapshot. Let's go here. Here. Let's search for vtable for snapshot. There we go. Vtable for snapshot. We have 3 3 pure virtual functions in there. Vtable entry size 0. Okay, well, we need to figure this out first. What is going on there? Let's go to put a breakpoint here if class name equals snapshot, int a equals 0, put a breakpoint in there, and we check what happens. Something fishy is happening. Let's see. Okay, there we go. Snapshot. Let's see. Memory. Vtable. Yeah. Class index. Okay. Vtable section. Alright. Vtable. Okay. Vtable entry. Okay. So function address is that number here. Yeah. And then let's see. 0. Alright. Function section. Oh, it's 0. Oh, I see. I see. Here's a problem. We are no longer recording virtual functions. Pure virtual functions. How do we fix that? Unknown entity. Okay, I think How do we write that? Basically, it need this check here needs to happen before this one here. Yeah. Because it's not a regular function, this pure virtual thingy. So I think what we do is we simply move this up here. Yeah. And then we say I would say we make a copy of this one and we put it here and then we call it continue. Then here we put this one here and we remove this. And then here we remove this and this. Okay. It's a it's not a real it's not a function pointer. Pure virtual function. Is pure virtual function. Okay, I think this will fix the problem. Yeah, it's a little hoopla that we have introduced when we were adding those exclusion checks here. Okay, but it should be fixed now. Snapshot, there we go. Okay, let's see. Okay, function address. Okay, there we go. Pure virtual entries, pushback, vtable. There we go. And another one. And then there will be another one. There we go. And then now it should end somewhere here with a 0. There we go. Okay, very good. Okay, so we have fixed that. Let me remove this again. And we get back to our function here at the bottom. There we go. Okay. Then good. Let's skip forward a bunch of times. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Okay, just to skip ahead some of the early ones, which are pretty uninteresting. Okay, what do we have here? Body module, which has 2 base classes. Okay, this one looks interesting. Let's see what we got. Okay, table index 2. Table index 2. Let's see. Base classes. Okay. Class index. Okay, behavior module. 2. Behavior module. Virtuals count 5. What? Is that unexpected? Let me see. 5. Well. On drawable bound to object. Okay. I mean, okay, what did we collect here? So we collected 6 functions. There are 2 pure virtuals. Okay. Let's see. We have a base here. No base, no base. Pure virtual base. How's that possible that we have 2 pure virtual bases? I would have expected 1 pure virtual and then 4 of these, but not this one. Where's this coming from? Is pure virtual true? Okay, but other than this, it looks pretty good. But maybe this is correct. I just don't understand it right now. Oof. Okay, so we are here right now. Undrawable bound to object. Undrawable bound to object. Huh. Okay, this is actually an interesting case here. Let's see. Let's go to the next one, number 3. Number 3. Good. Let's step in here. So we have 2 base classes. So the base class is behavior module. Yeah. We are looking at base vtable index 3. Okay, let's step in here. Let's look at our core stack. We are now 2 levels, 1 level in, 2 level in. Okay, so virtuals count is 0. We are here at 3. And here we have again another 2 base classes. Base class is object module. Object module, okay. Then here we go. Now we're at level 3. Level 3. Index 3. Okay, and we have another base class. Yeah, okay, so this one goes really deep. That's good. Okay, so module. Is that now the lowest or is there another? It also has 2 base classes. My gosh. This thing is going deep. So, okay, so we are now at number 2. Number 2. Hold on. We have another 2? Are you kidding me? Module. Module has 2 base classes. Memory pool object. Okay, here, finally, it ends. It ends here. Good. So, what do we have? Number 3, collect virtuals. So now, in here, we should have 0, yeah? And count without detours. vtable 2, I think it only has 2 destructors. Yeah, so this one will get nothing and the virtual count is 0. Okay, that's fair. Good. A virtual count is 0. Okay, so now we should add 0 to this thing because it only has detours, right? Yeah, there we go. Okay, so next base class, and this is second base class, which is a snapshot. Snapshot. Oh, but this is not right, or is it? The snapshot 3. It has vtable 3, so this one virtuals count is 0. Count without detours. I wonder if our counting is correct here. I have the impression it's incorrect. 3 smaller than 1, 2, 3. Preload assets. Could that be? Module preload assets. I think there is something deeply wrong here. Vtable. So this one will give the preload assets is base true. Module preload assets. Module preload assets. It's here. Yeah, it is a base. 1, 2, 3. 1, 2, 1, 0, 1, 2, 3. Yeah. I think we need to okay, so this is a snapshot. It was in. Can we find this here, please? Module. Vtable for module. Here. Oh shit. So so the CRC, Xfer, and load post process from snapshot, they are here. Why are they there? Why are they not below these? No, why are these not at the top? Oh, I don't understand. Why are these three not at the top of these other ones here? These five. Huh. What? Oh boy. I don't know. For some reason, oh man. Oh man. Oh man. Oh my gosh. That is I don't understand. I don't understand. Why is this down here? Is it maybe that the position we actually write this will determine? Yeah, maybe it's not. Maybe it's not the position that we. But then how do we know? How do we know? How do we know? Sim- I don't know how to program this because, like, how does this determine that the CRC and the XOR and the load process should be located here when it overrides the functions, pure virtual functions from here? I don't understand. I don't understand how to make this link between pure virtual functions and the higher ups. I don't know how to do it because there seems to be no fixed order and how these guys are created. Or is it? There must be. There must be. Oh. Oh. I think this one here gives us the information. The secondary vtable. Because here we know that this thing here refers to can't see it here right now, but this thing here, this thing refers to this, so that we know that these functions refer to the pure virtuals. Yeah. 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 Okay, this is a decent discovery, I would say. Yeah, yeah. Okay. Okay, that means we should collect those guys here. Which also means we need to get records of these non-virtual thunks. Otherwise we wouldn't know what it is. What is this thing? Let me see. Is this something that we can find here? No. No. Here. Non-virtual thunk. Is it only one? Yeah, it's just one. Non-virtual thunk. Okay, and these non-virtual thunks, they... Yeah. Okay. Okay, I think what we need to do is we first need to pass those non-virtual thunk thingies here. We save all these in one container. And then we use this to... First we collect it, and then we think about how we use it to build stuff with it. Yeah. Okay, yeah, I think this is a way. This is a way. Okay, so we actually don't need it. But now at least I understand how this is useful for us. Yeah. Because this clearly tells us that these guys belong to the second base class and that they have these names. And so that means we can match them with these things, and then we know exactly that these guys override these other pure virtual functions and what names these have. Yeah, okay. I understand now. We just need to program it. Yeah, we just need to program it. Oh boy, this is quite a journey. This is a journey, yeah. Okay, I now understand how to use the non-virtual thunks. To use the non-virtual thunks to get the to get the pure virtual function names and overlaps, I think. Need to write more code. Okay, good. Then yeah, I think we have a plan. Then next video we will first read in all the non-virtual thunks into one container, and then just trying to see if there's anything else in there. Or if there are only non-virtual thunks in there. Well, I don't think it makes sense to mix this with the regular functions, because these are compiler generated trampoline functions. So I don't think that we only need them for the vtable consideration, I think. Yeah. Okay, so next session we will pass these guys, put them into a container with the address and the name, and then we will read in the secondary vtables with these thunks. Yeah. And then we need to associate them with the but I'm wondering, this one, but this one, with these we only know then the overlaps with I'm wondering, like, how does it work with the things that don't have this offset here? So all vtables, all vtables that are at offset 0. How does this work then? Because they don't have these non-virtual thunks, right? I don't know. Guess we have to figure it out somehow. Okay, yeah. we have a plan. I hope it will work out, but it's not yet clear to me. Not yet 100% clear. All right, I think I will take a break here. It has been just 1 hour 50. It felt like 3 hours. It felt long, yeah. We didn't get all that much done. This one doesn't correctly work, but okay, it is something. It is something. Good, then, yeah, we take a break here. I wish you a great day or night. Until next time, goodbye.